Welcome to another episode of the Pharmaceutical Calculation Solve Along. So, at some point in time, when you're in pharmacy school or if you're practicing as a pharmacist, one of the things you would inadvertently have to do is to alter or change the concentration of a pharmaceutical preparation. You may either have to make it more dilute or perhaps at some point in time maybe more concentrated. So in this video, we are going to continue our series on how to master dilution and concentration calculations. And this video is part 2 of a 5-part series. If you'd like to watch the first video, I'll put a link to that in the description, and I would also put it in the card. Now, if you're watching the video live, just put your questions in the chat box and I'll address them. Or if you happen to watch the replay, then put your questions in the comments and I'll get to them as soon as I see them. But let's dive right into the very first question. So here the question says, a pharmacist needs to manufacture a 7% boric acid ointment using 34 grams of a 10% boric acid ointment. How many grams of pure ointment base is required? Round to the nearest tenth. Do not include units. So let's analyze the question. Now, typically for your concentration and dilution type questions, there are two main ways you can actually solve these type of questions. You could either use the alligation method, or you could either use the algebraic approach, the C1 Q1 plus C2 Q2 equals C final Q final approach. So what we'll do is we'll look at the same question using both approaches so that you can have a flavor of how to solve the question using those two methods. So let's start off with the alligation. And the way the alligation method works is you set up your grid. And if you need a more thorough or more exhaustive lesson on the alligation, I have videos on that, so I'll put those links in the description as well. Now, the way it works is you set up a grid, and on the grid in the top left hand you put the highest concentration. So in this question, we need to identify what the highest concentration is. The highest concentration here will be the 10%. And then the desired that we are looking for, or the desired concentration, is the 7%. That means that we need some quantity which has a concentration lower than 7%. Otherwise, there's no way you can dilute the 10% down to 7. So we don't have a number, but what we've been given is information in the question. And so that's one of the tips or tricks I wanted to share today. We're looking for this phrase that says pure ointment base. So that's a key phrase. And the pure ointment base indicates that there is actually no boric acid in it. And so the concentration there will be 0%. So now if you go back to the grid, your higher concentration or your highest concentration is 10. That goes in the top left. Your desired concentration is 7. That goes in the middle. And the lower concentration is going to be 0. So that's the first piece in the puzzle. Okay. But what we need to do is we need to subtract the desired concentration, which is 7, from the higher concentration, which is 10. So 10 minus 7 is 3. And that goes to the bottom right. Now the 3 indicates the parts of the pure ointment base, or the 0% component. That's what that number actually means. And then we do a similar thing. We take the desired concentration, which is 7, subtract the lower concentration, which is 0. So 7 minus 0 is 7, and that goes to the top right. Now this 7 indicates the parts of the 10% ointment. So assuming you are making a cake, you have flour, you have sugar, 1 part flour, 1 part sugar. Similar analogy here. We have 7 parts of the 10% ointment and then 3 parts of the pure ointment. So regardless of how much you're making, that's always going to be those ratios. What we've been given also is the actual amount of the boric acid. We don't know the total quantity to make, but we do know that we want to use up the 34 grams of the 10% boric acid ointment. So at this point, the way we set the solution up is we take the parts of the 10% because we know that to be 7, and that 7 is representing the 34 grams. So what we can do is set up a proportion to say that if we have 3 parts, then what would that be in terms of grams? Okay, so the parts of the 10% go with the quantity of the 10%, and then the parts of the 0% will go with the quantity which we actually need to identify. So at this point, we can go ahead and solve for the unknown, which is x, and that will be equal to 3 times the 34 grams divided by 7, and we end up with 14.6 grams because it says to the nearest tenth, and actually do not include units. So if this was on maybe the NAPLEX board exam, you actually put 14.6 as your solution. So that is the way you will solve this particular question using the alligation method. Let's see what it will look like if you were using the algebraic approach. So here the question says, a pharmacist needs to manufacture a 7% boric acid ointment using 34 grams of a 10% boric acid ointment. How many grams of pure ointment base is required? Round to the nearest tenth, do not include units. So the same question, but we're going to solve it using the algebraic approach. And that implies that you have C1 Q1 plus C2 Q2 being equal to C final Q final. And so what we can do is just put in what our C1 Q1 will be. So C1 Q1. So let's say C1 will be the highest concentration, so that will be 10%. And then the Q1 will definitely be 34 grams. So we're getting that information from here. And we can say our C2 will represent the concentration of the pure ointment, so that will be 0%. And the quantity of the pure ointment, we don't know that, so let's just call that Q2. And for C final, we desire a concentration of 7%. And the quantity, we actually don't have that given to us directly, so let's just call that QF, Q final. But what we do know is that your final quantity should be equal to the sum of the 34 grams and the quantity of your pure ointment base. That we do know. You're adding those two components to give you your final quantity. So we can go ahead and begin to substitute all this information into the original equation. And that would imply that you now have 10 from your concentration 1 times 34, which is the quantity, plus the concentration of the pure ointment base, which is 0, times quantity, which is Q2. And that should be equal to the final concentration, which is 7, times QF. But notice that QF is basically the same as 34 grams plus Q2. So we substitute that into wherever we see QF, which is right here. And now we can go ahead and do some algebra. So the 10 times the 34 gives us 340, plus 0 times any number will give you 0, so that goes to 0. And that is equal to, we can distribute the 7 over the parentheses, so 7 times 34 will give you 238. And then we can distribute the 7 over the Q, so plus 7Q. We subtract the 238 from the 340, and that gives us this expression. So 340 minus 238 is 102 or 102. That should be equal to 7Q2. We divide both sides by 7, and we end up with Q2 being equal to 14.6. So we do end up with the same quantity as we determine using the alligation method. And most of the times you will notice that if you know what you're doing and you have the concentration of your higher and your lower strength and the desired, then the alligation method normally is quicker, much more faster. But regardless of the approach, you should end up with the same solution. All right, so I don't see any questions in the chat. So we can proceed to the second question for this particular video. All right, so here the question says you have dopamine hydrochloride injection, which is available in 5 milliliter ampules of 30 milligrams of dopamine hydrochloride per milliliter. The injection must be diluted to 0.025% weight by volume of dopamine hydrochloride before administration using sodium chloride injection as a diluent. How many milliliters of sodium chloride injection should be added to 5 milliliters of the injection? So here again, let's analyze the question. What we're actually looking for is to get a target concentration of 0.025%. And this question actually is fairly similar to the one that we just did previously, in terms of we have a final concentration and then we have some original concentration, which is now given to us in terms of milligrams per milliliter. Okay. And then we have the diluent, which is your sodium chloride injection. Now notice that this 0.025% actually talks about the amount of dopamine hydrochloride in the solution. That's what this percentage represents. So if you take sodium chloride injection, there is no dopamine hydrochloride in there, and so your concentration there will be 0. Okay, so that's important. Now, although this question is similar to the previous one thing we need to do is actually, for convenience, to convert the milligrams per milliliter to percentage concentration to make things easier in terms of our solution approach. So let's start off with that. Let's start off with the 30 milligrams per milliliter. And we are converting this to percentage strength. So the first thing we want to do is get the milligrams and grams. And 1,000 milligrams make up 1 gram. So that cancels out. And now what we have is 0.03 grams per milliliter. But we need this in a percentage strength, so we can say that 0.03 grams in 1 milliliter is equal to some quantity in grams out of 100 milliliters. So this grams in 100 ml actually is the definition of percentage concentration. All right, so if we solve for X in this instance, whatever value we get will be the percentage concentration. So X equals 0.03 times 100 milliliters divided by 1 milliliter, and that gives us 3%. So we have a 3%, we have a 0, and our desired is somewhere in between. So that makes sense, and we can go ahead and use our alligation method. So once again, we can draw the grid. And in the top left, we put the highest concentration, so that will be 3. We put our desired in the middle, so 0.025. And in the bottom left, we put the lower concentration. In this case, it's our diluent, sodium chloride injection. All right, and since there's no dopamine hydrochloride in there, then that value here will be 0. So now we can go ahead and go to the next step, where we take the desired concentration and we subtract that value from the higher concentration. So 3 minus 0.025 actually gives us 2.975. And this number you put in the bottom right, and it actually represents the parts of the sodium chloride injection, or the 0% component. We do a similar thing, and this time what we do is we take the desired concentration 0.025, and from that we subtract 0, which is a lower concentration, and that gives us 0.025, and this is the parts of the 3%. So now that we know the ratios of each of those components in your mixture, we actually need to determine the exact volume of the diluent, which means we are interested in the parts here, the 2.975 parts. But what we have is the volume of the 30 milligrams per milliliter. So your 3%, we have 5 ml of that. So the way that will work is we go ahead and we take the parts of the 3%, which would be 0.025, and that goes with the 5 milliliter. And we can set up a proportion and say that, what if we had the 2.975 parts? What volume would that represent? Okay, so once you understand what happens, it almost reduces to a simple proportion. Okay, now let's go ahead and solve for X here. Now X is going to be equal to the 5 milliliters times your 2.975, and then you divide that by your 0.025, and then once you do the math, you end up with 595. Okay, so while this question is similar to the previous one, let me just point out the main difference, or one of the main differences. We had to take an additional step to convert the milligrams per milliliter to percentage concentration for convenience. The other thing we want to use as a reminder in terms of a tip is, anytime you are converting from milligrams per milliliter to percentage concentration, you could simply take the number and basically shift the decimal one place to the left. So what I mean by that is, we started off with 30 milligrams per ml. You shift it one to the left, so you end up with 3% like we did here. And the reason is, you're going to actually end up dividing by 1,000 and multiplying by 100 ml, which is almost the same as dividing that value by 10. So as a general rule, if you want to move from milligrams per milliliter to percentage strength, you can simply take that number that you have there and shift the decimal one place to the left. All right, so that's a useful trick if you want to actually move very faster. I still don't see any questions in the chat, so I'm going to move on to solving this same question using the algebraic approach. Now, what we will notice is that may involve a lot more algebra, but you would end up with the same answer. So let's see how that will work. So now, in terms of what that implies, you have C1 Q1 plus C2 Q2 being equal to C final Q final. And we can start off by identifying what our C1 is. So our C1 actually is 30 milligrams per milliliter Q1 is equal to 5 ml or 5 milliliter. C2 is equal to 0%. Q2, we don't know that, but we can put Q2 there as our variable. And for C final, we want a concentration of 0.025%. And the Q final, we don't know that as a value, so we put QF. But what we do know is that your final quantity is going to be equal to the 5 milliliters plus the Q2. Okay, that we do know. So anywhere we see QF, we want to put this expression in there, 5 ml plus Q2. Actually, let me write the QF much better. Much better. Okay, QF. So we have that, and now we can substitute in there. So for convenience, it's better to convert once again the 30 milligram per milliliter to percentage concentration. And here we'll just go ahead and use the trick I was talking about in the previous example. We will shift the decimal one place to the left, and we will end up with 3%. Okay, so if it was slightly confusing, just check a few minutes before this particular portion of the video, and we are making use of that important concept. Okay, so now we put all these values back into the equation. So we have 3 times 5 plus 0, which is the concentration of your diluent, times Q2 being equal to 0.025 times QF, which is Q final, but we're going to put the 5 and then the Q2 in place of the QF because we are making use of this particular equation. So we can go ahead and do the algebra. So 3 times 5 is 15. 0 times any number is 0. So that goes to 0. And that should be equal to 0.025 times 5, which ends up being 0.125 plus 0.025 times Q2. So we have 0.025 Q2. So we can subtract the 0.125 from both sides of the equation. We have 15 minus 0.125. That's equal to 0.025 Q2. Okay, wonderful. Now we are almost there. So what we need to do next is divide both sides by, actually before we do that, let's just simplify the left-hand side. And that should essentially give us 14.875. I think that's correct. And that should be equal to your 0.025 Q2. And then we need a Q2 by itself. So we divide both sides by 0.025. That cancels out. And then that implies that your Q2 is actually equal to 595. Basically the exact same answer as we had when using the allegation. All right, so these two examples illustrate how to deal with questions when you have all the information that you need in terms of the higher and the lower concentration and your desired is in the middle. The take-home message from these two examples is you may not be given a number for your lower concentration, and in such cases you want to check to find out whether indeed it's a diluent. If it's a diluent, then there is no active pharmaceutical ingredient in there, no API in there, and so your concentration will be 0. So that's a type of question. Then the other thing that we also reminded ourselves of is the alligation method and how you can quickly convert from milligrams per milliliter to percentage concentration. Whatever that value is, whether it's 30 milligrams per ml or 40 milligrams per ml, simply shift the decimal place one place to the left and you end up with the value you need for your percentage concentration. So I still don't see any questions in the chat box. Now, if you like this video, just give it a like and then share it so your other colleagues and friends can benefit from it. And I'll see you in the next video.